Okay, while the other video is processing, I am going to talk about two curves. And also, I did forget in BC for you guys, you would do slices perpendicular to both the x-axis and y-axis. So we'll talk about this one in a little bit. First, I want to get you used to this method here so the first video was between the function and the x-axis, and now we're going to talk about doing cross-sectional slices between two curves. All right, so let's see, where's that AP question? So here's one. And again, I'm not going to, I know you guys can find the area. You should be able to do all this because you learned this, or you're supposed to learn this last year. All right, so this is not just a BC topic, it's an AB topic as well. So anyway, I'm just going to focus on part C. Okay, so we have these two functions here. We have y equals 2x, and we have y equals x squared. And what we're told is that this picture now here, this graph, so here's my 2x function and here's my x squared function, and this is the point 2,4. Just because if I move that window down, I'm going to lose it. This is my region R. All right, so we have a solid with the same base. Oh, wait a minute, part B. Oh, all right. We'll go back to this later. So we have another solid, has the same base as R. So this is the base of the solid in the plane. The cross section is perpendicular to, darn, I don't want the y-axis. Let me find an x-axis one. I want to do y-axis later. Okay, sorry about that. Scratch. All right, let's do this one. So here's our picture. We have the functions y equals root x and y equals x over 2. Let me get a clean piece of paper because that's going to irritate me. I'm wasting and using more paper doing this, but so here's our function. Right, this is the point 4,2. This is the region R. And we have functions y equals root x and y equals 1/2 x, or x over 2, right? So this is the square root of x function here, because it's curvy, and this is a linear function, so it just makes sense. All right, so in part B here, this is the base of a solid, and for the solid, the cross sections perpendicular to the x-axis are squares. Okay, formula for a square is side squared, okay? And what that means is that the side of the square, wow, that's really hard to draw. The side of the square is going to be the width between the two curves, right? So remember, I have to rewrite this formula in terms of x. So the side of the square, the width here, right, one of these perpendicular cross sections is going to represent the side of the square. And the side of the square is just going to be top curve minus bottom curve. So it's going to be root x minus 1/2 x. Make sense? So my a of x is going to be top curve minus bottom curve quantity squared. Now, I want you to be very careful because, you know, you're not going to have to simplify your work in AP. But if you square that, it's not just x minus, 1/2 x squared. Right? That's a binomial in there. So you'd actually have to FOIL that out to get the, total or the long polynomial. But you don't have to do that because what you also know is that the limits of integration go from 0 to 0 to 4, right? Along the x-axis is the domain. So the x-axis. All right, so the volume is going to be the integral from 0 to 4 of root x minus 1/2 x quantity squared dx. And this is the scoring rubric, so I'm going to bring this down here. Here it is. That's all you would have to write down. All right, and you could expand that. Again, you would have to FOIL it, right? You wouldn't just get x plus x squared over 4, like I said. You'd have to FOIL that out because it's binomial. But This is, you know, where maybe, I don't even know if this was a calculator section or not. This is from the 2009 test. So generally you'd have to, and you still want to write out as much as you can. But, you know, the grader is going to know. If you can write that out, you're on the right track. And then you get to use your calculator for the whole thing. So let's use the calculator, right? So we go into y equals, and I'm going to clear out that last function. Now you got to be careful putting your function in. Let me turn on my overhead light because it's kind of dark in here. See if that helps. Yeah, that's better. Okay. So just be careful putting your function in. So I'm going to put parentheses, root x minus 0.5x, close the parentheses and square it, right? And I'm going to hit the graph key. And this is terrible, terrible graph. So I'm going to do a zoom 4 to see if that comes in any better. Oh, that's awful. Terrible graph. How about a zoom 0? That's better. Okay, so when worst comes to worst, use zoom 0. That's a zoom fit. And generally, it'll put the whole picture that you need to see in the viewing window. All right, and so then I'm going to do second calc 7 from 0 to 4. And it's going to shade it in, and I get 0.533. So the volume here is about 0.533. And, you know, I can check against the answer 8 divided by 15 is 0.533. So, you know, if you did this by hand, you could get a nice little rational number there. But you're allowed to use your calculator, so use your calculator. Okay, do what's easiest for you. Remember, you're only going to have 25 minutes, so you need to make the most of that time. Let's see what else is here. Here's another x-axis one, so let's look at this one. So we have this region R, so I'm looking at part C here. The region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. So we have a different region, but we have the same cross-section. It's a square, right? And our functions here are a little more crazy. So we've got y is equal to sine of pi x, and y is equal to x cubed minus 4x. This is definitely a calculator problem. And you know that the sine of pi x is going to be this function here, right? And x cubed minus 4x is going to be this bottom function, but you could put them both into your calculator to inspect one by one. So if I put the sine of pi x in y1 and x cubed minus 4x into the second one, and now I'm going to have to change my window. Make sure you're in radian mode too on exam day, please. Calculus is always in radian mode. So let me do a zoom 6. And here comes the first one, the sine, and then here comes the second one. So if I, you know, want to trace in and zoom in around that origin, then I'll see a better picture that more closely mimics the one I'm looking at, right? So here it is right here, this region right here in the calculator. Okay, so what do I know? I know what my top curve is, I know what my bottom curve is, I know that the area of a square is side squared, and I know that based on this picture, if I cut a slice, so just think of a rectangle from top curve to bottom curve, perpendicular to the x-axis. If I cut a slice there, and that's the side of the square, then the side of the square is going to be top curve minus bottom curve. Now, you need to be careful in a problem like this as well, because remember, it's top curve minus bottom curve, and that means that this negative sign is going to distribute into there. I wouldn't distribute. I would leave it, oh, I'm sorry. I would leave it alone. Why? Because a of x is equal to this nightmare squared, right? Side squared. And again, you know, your volume is just going to be the integral from a to b. Well, this is going from 0 to 2 in the x direction. I throw my function in there. I'm not going to expand it out or square anything. I'm going to leave it alone. That way I don't screw it up, right? That's what I'm going to show my grader in my work, and then I'm going to let my calculator do the rest. If you do that, so let's see, this was c, right? There's your function. And as you can see, they wanted to see in this particular case, and it's definitely, like I said, a calculator problem, they wanted to see the integral that represents the volume, and then let your calculator come up with the answer. All right? So if you put that into your calculator, this is what you have to put into y1 here, and you have to put it in carefully. So let's just do that to check, to make sure we're putting it into the calculator right, because that's half the battle actually. So I'm going to put a parenthesis. I'm going to do the sine of pi times x. I'm going to close that little parenthesis, minus parenthesis, x cubed minus 4x. Close that parenthesis, x cubed minus 4x. Close the parenthesis and close the outermost parenthesis and square it. Alright, and when I do that, all of my area is going to be brought above the x-axis. And now, if I do second calc 7, from 0 to 2, it shades it in, and I get 9.978, okay?